Alright, welcome back. This video is a continuation of my first video on projectile motion, that is horizontal projectile. In the first video, I derived the following equations. For vertical component of the motion of the body, I have that my uy is equal to 0 because the case where the body is dropped from rest. My vy equals g times t, and the vertical acceleration, because this body is under gravity, it's also a type of motion under gravity. It is equal to g, that is acceleration to gravity. And the vertical displacement covered by the body is half gt squared, okay? That is to say, at any point, for instance, point E, okay, we can decide to find the vertical distance falling. Alright, so for the horizontal motion, I also derived the following equations. We say that the initial velocity in the horizontal direction, let's call that u, so they can use another symbol, v or whatever symbol. Now vx is u because that the body does not accelerate in the horizontal direction, so the value of vx also remains the same throughout every point along the path. The horizontal velocity stays the same, and x equals u times t. X equals, my pen is not wanting to write u times t. Okay, now let's say the particle strikes the ground at point q. When the particle arrives at point q, that's the ground level, what happens? Let's see what happens to all these parameters. The final velocity vy will be equal to g times t also. This t becomes a time of flight, time taken to go from the top to this point q. That's that t. And then the horizontal, and then the vertical displacement y will be equal to the height of the platform from which the body was projected. Okay, so we say h equals half gt squared. Now these two times are the same, so the time taken to reach this point, the same time we apply here to determine the height of this body, the height of the platform from which the body was projected. Okay, so that is that for that. Now for the horizontal motion, we have our Vx remains the value of u, does not change, and then the x will have become the range, u times t. Now the time in this equation equals the time in this other equation, okay? Now I want to sketch some graphs. Let's say at point q, how does Vx vary with time? I showed you that of Vy in the last video, okay? So you can take a look at that video to know. You can take a look at the video to know how it varies. So this is Vx with time. We say Vx does not change, so it's a constant parameter. It remains constant throughout. Okay, so it's just a straight line. It's independent of time. All right, so you can also draw the variation of in case you're asked to do all these things, horizontal displacement or vertical displacement, y. How does y vary with time? How does y vary with time? The equation is this: y equals half gt squared. So it varies this way. Distance y, that's distance falling, varies non-linearly with time. It's a curve, it curves continuously upward. So at this point here becomes the height. If this is where it hits the ground at point q, it means that this becomes the height of the platform from which the body was projected. Okay, so how does x vary with time? The horizontal distance covered, the horizontal displacement of the body, how does it vary with time? Okay, so we have this is distance, this is time, it varies this way. Okay, so because the velocity is constant, Vx is the slope of the graph, so it's the linear variation with time, that is x varies linearly with time. Alright, so the acceleration, it varies, is constant for the vertical direction, and for horizontal direction, the acceleration is 0. Okay, let's come back here again, and we want to find out the differences or the difference between distance and displacement, because we said distance is the length of path, the path length, that's the distance covered. Then what is the displacement? The displacement is just, in case you ask to find the displacement, you just will draw a straight line that links this point of projection to the end of projection, from the point of projection to the end of projection. So that's the displacement. So I can find the displacement. Let me call this S as my displacement. So while distance is the length of this path, displacement S using Pythagoras theorem is x squared plus h squared. So that the displacement is equal to the square root of x squared plus h squared. Why is this so? Because of course this is more like a right angle triangle now, this one 90. So using Pythagoras theorem, we have that as the displacement of the particle. Different from distance. Distance is the arc length covered by the body. Okay, now I want to look at the resultant velocity v. Let's say of the body at point Q or at any point, because at any point in time, let's say point A, the resultant velocity is acting this way, the vertical velocity acts this way. That's my V1. Okay, so that at point A, the resultant is just a line drawn at tangent to a point A here. Okay, now it makes a right angle triangle there. This is my x component, that is Vx. My Vy component act this way, Vy. Okay, so this is my V, which is the resultant velocity. I can find that by Pythagoras. My V equals what? My Vx squared plus Vy squared. Then I take square root using Pythagoras theorem. Okay. Now this angle here, theta, is the direction of the resultant velocity. So I can use tan theta. That equals Vy component. That is, if I close this up to make a right angle triangle, this is also my Vy over Vx adjacent, opposite rather, over adjacent. So that my theta, so if I have my Vx and Vy, I can find the direction of my resultant velocity, tan inverse of Vy divided by what? Vx. Because an exam has to find the direction of the resultant velocity.